Welcome back to Module 15.3. Let's take a look at how we can simplify expression using the properties of rational exponents. All right, so this particular example here says change the following expression to an equivalent expression in exponential notation. Okay, assuming all the variables are positive. So basically, my final answer need to be in some sort of exponential notation. So these two particular examples, there are a couple ways we can, there are actually two ways we can do this. We can either use this concept we learned about multiplication and division of radicals, or we can actually convert them into fraction exponents first. So I'm going to do both ways for right now, but then quickly, I'm going to use more of, this is the same problem. Then I'm going to quickly use this, begin to talk about applying other exponent rules, as well. So basically, right now, both my radical, have the same root, and I'm doing multiplication, so this is all one term. So technically, I can actually write both same roots, and its radicand together under the same roof, kind of like. So basically, I can rewrite this problem as cube root of y to the fifth times y to the sixth power. So just like before, when we first saw this, we will actually split them apart. So right now, we're looking from the other perspective, kind of put them back together under the same roots. So, and the reason why I'm doing that, so I can actually quickly say this is y to the fifth times y to the sixth. Base are the same, and multiplying, we add the exponent. So that will be cube roots of y to the 11. All right. So this is what I'm going to do right now, I need to write my final answer as an exponential notation. I know that if I take the exponent divided by the roots, it will actually give me 3 remaining 2. So that means 3 y's can go outside. Y times y times y is y to the third, and 2 of them remain inside, which is y times y, which is y squared. I can write my answer this way, but this particular example wants me to write them as an exponential notation. So now I'm going to go back and convert them into fraction exponent. Exponential notation here will be fraction exponent because I'm dealing with a radical. So my base is still y. All right. Denominator is the roots, which is 3. Numerator up here means my base is raised into that power in the inside the radical. So this becomes y to the 11 over 3. So the reason why I'm purposely doing it this way, so basically the shortcut I was mentioning before when we were simplifying radical, where we take the exponents, where did I put it at? Where we take the exponent divided by the roots. Those exponents, the 11 is basically my numerator of the fraction exponent. Those roots is basically my denominator of the fraction exponent. So that's the reason why it's not really a shortcut. The exponent divided by the root is literally an exponent rule where radical becomes division of the exponents. Division of the fraction on the exponent. That's why taking the exponent divided by root kind of makes sense when we simplify, because we can actually rewrite them this way. All right, so what's another way of doing the same problem? It's basically just go ahead and convert each radical into fraction exponents. So this very first one can be written as y to the 5 over 3, because denominator determines the roots, times y to the 6 over 3. But we know 6 over 3 is the same thing as 2. But since we can use this in the calculator, let's go ahead and do that. What I mean by using a calculator is when the base are the same and the base are multiplying, we're supposed to add the exponents. So that will be y to the parenthesis 5 over 3 plus 6 over 3, or you can type in 2 either way. Convert to a fraction, that will be 11 over 3 power. Okay. All right, so for this one, this problem actually wanted me to say, okay, this is a square root, so my base x is actually raising to the denominator determines the roots, the numerator tell you exponent is raised to that power in the inside. So this is x to the 3/2 power. So this one you can kind of look at, you can tell this is going to be x to the first power, right? Because the exponent divided by the root is going to be x to the first power. So, or I can just write it as x. Or I can write it as x to the 3 over 3, which we know is going to be 1. All right, so when the base are the same and the base are dividing, okay, we're supposed to subtract our exponents. So that will be 3/2 subtracts 1. 3 over 3 is 1. So that will give me half power. So that will be x to the half power. All right. Or this problem, I can actually, this problem, technically I cannot put these two x's within the same radical because the roots are different. One is square, one is cube. So this problem, you actually cannot put them under the same radical. You got to have the same roots. This rule actually specifically is saying it got to be the same radical, same roots before you can put them all under the same roof. So doing it this way is probably the only way. All right, let's try some other rules. So this is a good example for using power rule because I see parenthesis and one term in the inside. So we will multiply the exponents. So the 5x to the 4/5 power means 5 times, right? So that means the factor of 5 is actually to the first power. And here I got x as another factor. So the outer exponent 2, multiply both exponents in the inside. So coming out of the parentheses should be 5 squared and x to the 8 over 5. Okay, 4 over 5 times 2 over 1 is 8 over 5. All right, simplify the following expression using rational exponents. So we need to write our final answer as rational exponents. So 5 squared is just going to be 25. This fraction exponent cannot be reduced, so let's leave it as x to the 8 over 5 power. All right, this one will be an example of product rule. But I can multiply the numerical number first. So everything is one term. I see x to the half power times x to the half power times x to the third power. So all those x's, all those exponents on top of the x is going to be added. Product rule, we add the exponent. 3 times 5 is going to be 15. So this is going to be 15 times x to the half times half is 1. 1 plus 3 is going to be 4. All right, this will be a quotient rule. But this particular example, I got 7 on top, 3 in the bottom. They cannot be reduced. So I'm still going to have 7 on top for answer. Oh, sorry. Kind of freeze for a moment. Sorry. 7 on top over 3. Okay, I got x on top. I got x in the bottom, so we will take the top exponent, subtract the bottom, so that will be half. Oh, sorry, I'm freezing pretty bad here. That will be 7 over 3, half minus 3. So let's see what that is. And if you ever hear me talking about the ancient Chinese secret, we can quickly do this. 2 times 3 is 6. 1 minus 6 is negative 5. So this is going to be negative 5 over 2 right away. So if not, we can always say half minus 3, convert to a fraction, negative half. All right, got to be very careful here. So we are basically we are saying this is x to the half power minus 3, which is x to the negative half power. So when I write this x to the negative half power, it's actually put the base x on the numerator. Okay, you actually put the base x as a numerator. So that means I'm gonna put my x as a numerator, negative 5 over 2 power. All right. The y, again subtracting, this is 2/3 minus y to the first power. So that's 2/3 minus 1. So which is y to the negative 1/3. So again, when I just write y to the negative 1/3 power, he actually puts the y on the numerator. So now I got myself where both the base x and the y has negative exponents. So both of those base will be flipped to the other side. Therefore, my final answer got to be only 7 on top, because that's to the first power, over 3, still 3 down here, x to the positive 5 over 2 power, y to the positive 1/3 power. Okay, so we got to write all our exponent as a positive exponent. All right, this is a good example for power rule. So we've done problem like this before when we dealing with exponent rule before. So problem like this is where we can go ahead and simplify. Okay, what's within the parenthesis. So like I mentioned before, there's multiple different ways you can do this. I just like to see it as x to the negative 1 power will flip to the top, become x to the first power. And so that means I got 3x on top already. Now one extra one come up, so I should have x to the 4th power on top. If you like to just say 3 subtract negative 1, that you can do that, which is still, again, x to the 4th power. All right, this y to the negative 3rd power will flip to the top, so that will give me a total of 5 of them on top, because I got y times y already, 2 of them on top. Now 3 more come up to the top, so altogether I got 5. So that's using product rule. 8 still 8. The whole thing is raising to the negative 1/3 power. So now 8 times x to the 4 times y to the 5th. The exponent on top of 8 is 1. Don't forget. So my outer exponent negative 1/3 will multiply all the exponent in the inside. So they all come out to be 8 to the negative 1/3 power. All right. X to the negative 4/3 power. Third, and y to the negative 5/3 power. All right. So if you want to put this a to the negative 1/3 in the calculator right now, you can. If you already know the denominator of that fraction becomes cube root. So cube root of 8 is going to be a 2. But having a negative exponent, it tells me now all these bases are going to flip to the other side of the fraction. So I have nothing left on top, which is nothing but a 1. The 8 will come to the bottom, become 8 to the positive 1/3, x to the positive 4/3, and y to the positive 5/3. All right, and 8 to the 1/3 is basically saying that's cube root of 8, which is 2. That's why the answer. That's why if you put this in the calculator, you should say 2. So that will be 1 over 2 x times x to the 4/3 times y to the 5/3. All right, so this actual video, we just using our rational exponents along with our product rule, quotient rule, negative exponent rules, and the power rules to kind of review our exponent rule a little bit. Now just using fraction exponents. Okay, so all the technique we learned in previous modules regarding to exponent rules, we still apply the same way here. It's just now we are dealing with a little bit of fraction exponent, which they all can become, which they all really indicated some sort of radical. All right, that will conclude this lecture video. Thank you for watching.